all of that to actual word problems. Okay? So, before we can actually dive into a bunch of word problems, we need to quickly think about what words mean what. So, if I was thinking about the operation of addition, what words mean addition? It's add, plus, combine. I was right there with you, Justin. What else? I don't know. I already said add on to. What about subtraction? Subtract, that's the obvious one. Minus, difference, take away. Less than sometimes means subtract. What about multiplication? Product, multiply. Word of, sometimes that's one that we always forget. Of means multiply. If I wanted 1/3 of 3, I would take 1/3 times 3. Division, quotient, divide, half. Okay, there aren't too many division ones. Alright, so let's go ahead and quickly get these jotted down. See if I missed increase by and more than. So for addition, keep in mind some of the words that you may see in a word problem for you to know that, hey, I'm supposed to start adding something. The obvious one we have is sum. Usually they don't just say add. More than, plus, added to, increased by. Subtraction. I think you said most of those. Less than, minus, decreased by, subtracted from, difference. Okay. So as you can envision where this is going, I'm going to give you a verbal sentence that you're going to need to convert into a mathematical model. Remember what we said about mathematical models yesterday? What are mathematical models? We wrote it in our notes. Or maybe you wrote it in your notes. Mathematical model is an equation. Got Jenna?
That describes a real situation.
Right. Which is what we're going to be doing today. It's describing real situations. All right, so we got addition and subtraction, multiplication, we've got times, multiplied by, of, as much as, we'll need multiplication, twice, product, and division isn't as exciting. Quotient, divided by, and then sometimes if you see a ratio of something, then that means you're putting it into a fraction, which is pretty much division. Okay. All right, so I'm going to give you a verbal phrase. See if you can translate it into a mathematical model. It's going to be our goal here. Ready? Okay. Can you turn twice a number decreased by 3 is 42 into a mathematical model. Twice a number decreased by 3 is 42. Don't need to solve it, just set it up. Assuming you all can solve it. Twice a number looks like what? Anybody? 2x. Now, twice a number is decreased by 3. Does that mean I'm going to do 2x minus 3 or 3 minus 2x? Because that does make a difference. Which is it? 2x minus 3. Good. Okay. So I'm taking that twice a number and I'm decreasing it by 3. So I'm going to subtract the 3. What do we do for the word is? Equals 42. Good. All right. Not too challenging, hopefully. Try this one. The product of a number and 12 decreased by 7 is 105. So the product, well, we all know that means multiplication. Well, it's being multiplied. A number and 12. Decreased by, we have that again, 7 is 105. So the product of a number and 12 looks like what? 12x, good. Why would I not put x12? Just doesn't look good, right? You can always put your number as the coefficient. Is decreased by 7 is 105. Simple enough? All right, let me get the hang of this. Try this one out. The quotient of a number and the number plus 4 is 28. The quotient of a number and the number plus 4. That seems a little funky. So the quotient of a number and the number plus 4. So quotient, we know that's easy. That's going to be what? Division. So I'm probably going to put some kind of fraction bar. Well, what's being divided? A number, so we'll call that x, and the number plus 4. So what goes in the numerator, what goes in the denominator? Yeah, so x over x plus 4 is 28. How would you solve that? Well, by x plus 4 on both sides. Good. So if I multiply by x plus 4 that way, it's going to cancel out. Multiply by x plus 4 that way. So that means I'm going to have x equals 28x plus minus 4, 32, 8, 9, 10, 11. And then we shall be able to solve that from there. Good. All right, so we feel good about translating. So for your homework tonight, this first section is just that. Okay, given the phrase, translate it. I don't even think they want you to solve it. I think it just says to translate it. Quickly check. Translate expression, use X. Yep, so all you're doing is just translating, so you're good. Feel good about that? All right, so now let's get into the actual word problems. So, when solving a word problem, well, these steps you might already know. But if you want to write them down, write them down. This just want to talk it through before we start anything. Your first step should always be to read the problem. Well, duh. That makes sense. Read the problem. Figure out what's happening. Step 2, assign a variable. And I am really, really picky about that step right there. I want to see you say, let x equal whatever it is that it is you're talking about. Okay? If I'm trying to find number of socks, then I'm going to say, let x equal number of socks. If I'm trying to figure out how many cheeseburgers I'm going to eat today, let x equal the number of cheeseburgers. Okay? Identify the variable. Identify what the variable represents. Okay? I'm picky about that, so make sure you do that. Step 3 would then be to write your equation. So look for those key words to translate from a verbal expression to a mathematical expression. Then solve it. And then this step 5. This is kind of important here. State the answer. Sure, we've been doing that our whole entire life. But you should be asking yourself, does my answer seem reasonable? If I was looking for the number of socks and I got a negative number, would that make sense? I have negative socks? No. Huh? If you lose socks in the dryer, I don't know. You guys lose socks in your dryer. Okay, so make sure your answer makes sense. And then for step 6, you should always then plug it back in and check. Okay? So read the problem, assign your variable, make sure you identify what the variable represents, write your equation, solve it, state the answer, ask yourself, does my answer make sense? And then check your work. Okay? All right, word problem time. Question. Stretching. Gotcha. All right, again, if you want to write the whole entire word problem down, feel free, but don't feel like you have to rush to write it. Remember, this will be posted on my YouTube channel, so if you want to go back and revisit tonight to make your notes better, you are welcome to do that. Are you ready? All right. Let's bring some geometry into our world. We all love geometry, right? The length of a rectangle is 1 centimeter more than twice the width. The perimeter of the rectangle is 110 centimeters. Find the length and the width of the rectangle. Okay. So what do we have? We have length of a rectangle, and we have something about the width. We are given perimeter, so that's important right there. I know that my perimeter is equal to 110 centimeters. That's good to know. All right. What's going to be my variable? Length or the width, Justin? The length you're going to make your variable? Okay, so if we do that, if I say x is equal to length, then what would be the expression for your width? Yeah, I would do it the other way around, right? Because your length has more things going in it. So let's make x represent the width. Because my length is equal to what? Well, what does it say up here? 1 centimeter more than twice the width. Well, if we said width was x, what does that look like as an expression? 2x plus 1. Good, Andrew. So 2x plus 1 is equal to my length. How do we find perimeter? Add up all the sides. How many sides do we have? 4. So what's that going to look like as an equation? Me personally, this is what I would do. I'm a visual person. I would make that rectangle, and I would label that x, I would label that x, I would label that 2x plus 1, 2x plus 1, but that's just me. So I like to see what's happening. So I usually like to make a diagram. So what's my equation? What plus what plus what plus what equals what? Are you guys okay with me just adding them up right here? So 2x plus 1x is 3x plus 2x, 5x plus 1x would be 6x. What would my constant add up to? 2 is equal to 110. All right, let's solve it. See if you can beat me there. Subtract 2, divide by 6. Is it 18? Did I do that right? At least, like, sure, I'll go with you. It's early in the morning. 108 divided by 6, 18, yeah. All right, so x equals 18. Is that reasonable? Sure, can I have a width of 18? Yeah. So my width is 18. What's my length? So double 18 makes 36 plus 1, 37. All right, well, let's check it. If I do 18 plus 18 plus 37 plus 37, do I get 110? Yes. So we know that we are good to go. Okay. All right. One down, more to go. Are you ready? All right, we won't do that one. 2 outstanding Major League pitchers in 2013 were Yu Darvish, played for the Rangers, and Max Scherzer, played for the Diamondbacks. Combined, they had 517 strikeouts. Darvish had 37 more strikeouts than Scherzer. How many strikeouts? I don't even know if I'm saying that name right. How many? Does anybody know? Huh? Am I? How many strikeouts did each pitcher have? I don't watch baseball. Kind of boring. Sorry if you play. Okay. So, what's the important information? Well, we got 2 pitchers. Combined, they have 517 strikeouts. Okay. Who should be the X? Darvish or Scherzer? Why? You're correct. Yeah, Darvish had 37 more. So think about making the variable term the smaller number. So since Darvish had 37 more, then we're going to make Scherzer become the X. So X is going to equal Scherzer's strikeouts. So then Darvish would be represented by what expression? X plus 37, good. X plus 37 equals Darvish strikeouts. All right, signed our variables. What's my equation? This one should be an easy one. What do you do with those 2 things? Combined means what? Addition. So what am I going to do with x and x plus 37? Add them together and equal it to 517. There we go. So x plus 37 equals 517. Go ahead and finish that. Figure out how many strikeouts each pitcher had. You guys get 240 for x? So x is equal to 240. So that means Scherzer had 240 strikeouts, which means Darvish then had how many? 277 strikeouts. I'm just abbreviating that. If you add those together, do you get 517? Yes, we know we did it right. Okay. All right, so those are pretty easy word problems. The rectangle, the hardest part was just knowing that we had to do perimeter. This, all it had was the word combined. Where they're going to get a little bit more challenging is when we do mixture problems. Let's do a mixture problem here. This is what I want to go to. All right, so we have a chemist must mix 8 liters of a 40% acid solution with some 70% solution to get a 50% solution. All right, so let's envision what's happening. I'm a chemist. I got 8 liters right here, an 8-liter container. And inside of that, I have a 40% solution. I guess let me draw it out. So here we have 8 liters of 40%. I want to mix in a 70% solution in order to get this to become a 50% solution. Right? Does everybody envision what's happening? So how much of this 70% needs to go into this 40% to up the percent of acid to 50%? So we read the problem. We hopefully understand the problem. Our next move is to assign the variable. What's going to be x? Yeah, so I want to know how much of the 70% is going to go into that, right? So x is going to equal the 70% solution. How much of it? Okay. All right, now let's think about what's happening here. If I have, and again, I'm a diagram person, if I have 40% of 8 liters, and then I want to add to that 70%, do I know how many liters that 70% is? No, so we're going to call that x. Right? That's going to end up being, what percent do I want over here? 50%. How much liters would be in that container? 8 plus x. Why is it 8 plus x? Right, I started out with 8 liters. I'm dumping x amount in. So I'm going to have 8 plus x. Is everybody with me? Or x plus 8. I like to put my variables first. Now watch how this works for your equation. What is 40% of 8? So on your calculator, do 8 times 0.4. What do we get? 3.2. So this part becomes 3.2. So I have 3.2 liters, well, for that solution. I guess I shouldn't have said liters. So just combine that together in a number. What's this going to look like as a term? Well, here we did 0.4 times 8, so here we're going to do 0.7x. Good. Equals, what's this going to look like as a percentage? 0.5 times the quantity x plus 8. Good. Do you want to get rid of the decimals, or do you want to keep the decimals? Which would you guys prefer? I don't really care either way. If I wanted to get rid of the decimals, what would I do? Just move all of my decimals over 1. Do you guys want to do that? Or do you want to stick with decimals? Okay, so if I multiply everything by 10, and I don't have any decimals anymore. Okay? Go ahead and solve that. Find your x. Did you guys get 4? So that means what?
4 liters.
Yeah, so we have 4 liters of the 70% solution. Okay? So those mixture problems are probably going to be the trickiest ones that you're going to see. Which they really aren't that bad. Alright, when you finish that, let's go ahead and grab some sleeves, or if you just want to keep working on paper, you can work on paper. We're going to do some practice problems. Make sure we've got these down.